Hello and welcome to today's class on likely questions on gas laws. Let's go! What is the volume of oxygen required to burn completely 45 cm cube of methane? Now, what is the question all about? The volume. We are asked to find the volume of oxygen required to burn completely 45 cm cube of methane. Now, what is the formula for methane? The formula for methane is CH4. So we're going to write the equation for the reaction. CH4 plus oxygen, because it is burning in oxygen. Now, this methane is what we refer to as an hydrocarbon. An hydrocarbon is a compound that contains carbon and hydrogen only. And when hydrocarbons burn in oxygen, they give two products, carbon 4 oxide and water. Please note this is very important. When hydrocarbon burn in oxygen, they give two products, carbon 4 oxide and water. Okay, so this will give us what? Carbon 4 oxide and water. So if I gave you something like propane, if I give you something like propane, and I burn it up in oxygen, what's it going to give me? It's still going to give me carbon 4 oxide and water, as long as it's an hydrocarbon. Anything hydrocarbon that contains carbon and hydrogen only, when you burn them in oxygen, it will give you carbon 4 oxide and water. Please take notes. Okay, so let's continue with our class. Now, this is methane, this is oxygen, carbon 4 oxide and water. So the next thing we're going to do is to balance the equation. So you have that carbon is 1 here, carbon is 1. Hydrogen is 4, hydrogen is 2. So what do? Oxygen is 2 here, oxygen is 2 plus 1. That will give us 3. So where do we start? Because hydrogen is 4 here, hydrogen is 2 here. So what do? So we add 2 here. So this will be hydrogen 4, 2 times 2, 4. Then oxygen is 2 here, oxygen is 2. Then this 2 is affecting everything here. So this 2 is affecting oxygen. So this 2 plus 2 will give you 4. But oxygen is what here? 2. So you add 2 here. 2 times 2, 4. It is balanced. Let's do it again. Carbon 1, carbon 1. Hydrogen 4, hydrogen 2 times 2. 4. Oxygen 2 times 2, 4. Oxygen 2 plus this 2. That's this 2 for oxygen here, making it what? 4. It is balanced. Okay, so this tells us that we're looking at what is the volume. So we're looking for volume of oxygen. So we have that 1 cm cube of methane, 1 cm cube of methane used 2 cm cube of oxygen. So 45 cm cube of methane, this is methane, 45, this is methane. So 45 cm cube of methane from the question will give us how many? 45 times 2 divided by 1. You cross multiply. This times this divided by 1. So that will give us 90 over 1. And that is what? 90 cm cube. Answer. Isn't that simple? Let's look at another question. Okay, so let's look at another question. A gas X diffuses twice as fast as gas Y. If the molecular mass of X is 32, calculate the relative molecular mass of Y. Now, this question is under Graham's law of diffusion. So what are we going to do? We're going to first of all write out our parameters. So what are the parameters? A gas X. So gas X diffuses 2 times as fast as gas Y. So rate of diffusion of this person of gas S is twice the rate of diffusion of Y. So the rate of diffusion of Y will be what? 1, because this is 2 times whatever this is. Are we together? Okay. Then if the molecular mass of X is 32, so molecular mass of X, this is X, so M1. So that tells you that everything about X is going to be 1 and everything about Y is going to be 2. So M1 is what? 32. Then we are looking for what? Calculate the relative molecular mass of Y. We are looking for M2. So it's very simple. Using the formula of Graham's law of diffusion, it says that R1 over R2 is equals to D2 over D1 is equals to M2 over M1. So from the formulas given here, we have rate of diffusion and we have molecular mass. So we're going to equate this with this. Is that okay? All right. So R1 from here is 2 over R2. Sorry, this is R2, please. So R2 here is what? 1. Then is equal to square root of M2. M2, we don't know. That's what we're looking for. All over, remember this is question mark. We don't know. Then all over, M1 is what? 32. So what do? In order to solve this mass, this square root here is going to cross the sign of equality. And when square root crosses the sign of equality, it will become what? Squared. So this will be 2 over 1 all squared is equals to M2 over 32. If this square crosses the sign of equality, to be what? Square root. Okay. So this will be 2 raised to power 2 will give us what? 2 raised to power 2 is 4. 1 raised to power 2, 1 over M2 over 32. So we are going to cross multiply. We have that 4 times 32 is equals to M2. This times this 8, this times this 12. So M2 is equals to what? 1. So let's look at another question. A given mass of gas occupies 10 dm cube at 4 atm and 273 degrees Celsius. The question says, find the number of moles. So it is very simple. Now the first thing we are going to do is to write out our parameters. So what are the parameters? 10 dm cube. Dm cube talks about volume. 10 dm cube. Please, if you have not watched my video on gas laws, I'm going to drop all the links on all the gas laws. Please watch them step by step so that you will fully articulate this, okay? Then the next thing you have here is 4 atm. Atm is what? Pressure. Followed by temperature, which is 273 degrees Celsius. Now, everything you must be solving in gas law, you must always convert your degree Celsius to Kelvin temperature by adding 273. So when you add 273, it's going to be 6, 14, 5. So 546 Kelvin. Then the question says find the number of moles. We are looking for the number of moles. So looking at the parameters we have here, which formula is going to go for that? So it will be what? PV is equals to nRT. This is ideal gas equation from the parameters given. PV equals nRT. We are looking for the number of moles. Now this molar volume of gas at STP is equals to 22.4. Definitely you're not going to use it here. The examiner just gave it to you to confuse you. So that is why it is very important you write out your parameters before solving, because when you write out your parameters, it's going to tell you, give you clue or tell you which formula you're going to use. Is that okay? Okay, so PV is equal to nRT. We can now solve. We are looking for N, number of moles. So if we make N subject of the formula, we are going to divide by RT over RT because we are making N subject of the formula. So cancel, 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 cancel. You have that PV over RT is equals to N. So we are now looking for N. P is what? P is 4 times V is what? 10 all over R. Now R is a constant, and the value of R as a constant is 0.082. 0.082 is a value of R as a constant. Then T is what? 546. 546. So let's solve. This times this will give us 40. Let me bring my calculator to solve the second one. Okay, so 0.082 times 546. That will give us 44.772. So you have that 40 divided by 44.772. That will give us 0.082 89341. So let's look at the options given. The options given include A. The options given include A, 0.89 mole, B, 1.90 mole, C, 3.80 mole, and D, 5.70 mole. So these are the options given. From what we have here, what is the answer? The answer is what? A, which is 0.89 mole. Answer. Isn't that simple? Let's look at another question. Okay, people, let's solve another question. The question says 200 cm cube of a gas at 25 degrees Celsius exerts a pressure of 700 millimeter mercury. Calculate its pressure if its volume increases to 350 cm cube at 75 degrees Celsius. So the first thing to do is to write out our parameters. And what is the parameters here? Cm cube is what? Volume. So V1 is 200 cm cube. Followed by T1. T1 is what? 25 degrees Celsius. Quickly add 273 to it. Remember, everything you are solving under gas law must be converted. The temperature must be in Kelvin. So add up. This will be what? This plus this 8. This plus this 9. And this 298 Kelvin. Then you also have this pressure. Millimeter mercury is pressure. P1 is what? 700 millimeter mercury. The question says find its pressure. So we're looking for P2. If the volume increases from this to at that. So the volume here, V2, 350 cm cube, to T2, 75 degrees Celsius plus 273. What will be the maths? The maths will be this plus this 8. This plus this 14 and 3. So 3428 Kelvin. I think I'm right. This plus this 8. This plus this 14. Yeah, it's correct. So from what we have here, we're looking for P2. So which formula are we going to use? We are going to use the general gas equation, which is P1V1 all over T1 is equals to P2V2 all over T2. So P1 is what? From what we have here, P1 is 700 times V1 is what? 200 all over T2 is what? 298 is equals to T1 is over T1. T1 is 298 equals to P2. P2 is what we are looking for times V2. V2 is 350 cm cube all over T2 is what? 348. 348. So we cross multiply. We have that 700 times 200 times 348 all over this times this 298 times 350 is equals to what? P2. So we're going to press our calculator. Now some of you will be like, auntie, what did you do? Some of you will be like, teacher Lisa, what did you do here? This is this times this. Now this one is bearing the coefficient of P. So instead of doing, so you have to be very fast because you know inside the exam hall there is no time. So this, what you're going to do is simply multiply this by this and then divide by the one that bears the coefficients, the one that bears the letter. So this times this times this bears the letter P. So quickly divide it because there is no time for you in the exam hall. All right, now you're going to press your calculator now and solve. I believe you know how to get your calculator in the Jamb hall. I'm going to make a video on it, so kindly subscribe to this channel so that you'll be updated. Now let's do our job. So you have that 700 times 200 times 348. That will give us 48,720,000 all over. Please note what I'm doing. Don't ever press your calculator and press everything. Divide time, this times this times this times this, divided by this times this and this. You may get a wrong answer. Please do it as I'm doing it, one by one. Solve the one on top, solve the one down. So let's solve the one down now. 298 times 350. And that will give us what? 104,300. You can see my my values now. So you are going to divide. So 48,720 million, 720,000, okay, divided by 104,300. So you have it to be what? 467.11401. So this would be 467. So let's look at the options we have. The options we have are, you have it to be A 342 millimeter mercury, B 1430 millimeter mercury, C 467 millimeter mercury, D 400 millimeter mercury. So what's the answer here? 467 millimeter mercury. So our answer here is what? C. Isn't that simple? Okay, next question. If a gas occupies a container of volume 146 cm cube at 18 degrees Celsius and 0.971 atm, its volume on cm cube at SCP is what? Very simple. Let's solve. Okay, so a volume, write out our parameters. V1 is equals to 146 cm cube at T1 equals 18 degrees Celsius plus 273. Remember, we are going to convert this plus this 11, this plus this 9, 29 Kelvin. Dominion. No voice goes on together. And this ATM, that's pressure P1, 0.971 ATM. Then its volume on CMQ, we are looking for V2. We don't know V2 at STP. So what you're going to ask yourself is, what is the value of standard temperature and what is the value of standard pressure? It's 273. So P2 will be what? P2 will be 1 ATM. Now, when we talk about standard temperature, it is 273 everywhere you go. But when you talk about standard pressure is dependent on what you were given in your P1 or in your P2. For example, as you can see, what we are giving here is ATM. So our standard pressure for ATM is 1 ATM. For millimeter mercury, it is 760 millimeter mercury. And for Newton per meter square, it is 1.01 times 10 raised to the power 5 Newton per meter square. Please, you need to have this off hand. You need to have this off hand, please. Very important. So the standard pressure depends on the units that you are given. That will determine what you are going to use. So in this case, since we are dealing with ATM, our standard pressure here will be what? 1 ATM. Simple. So let's solve.
Okay, let's repeat.
So what do we do? Using the general gas equation, V1 all over T1 is equals to P2V2 all over T2. So what is P1? P1 is 0.971 times V1 146 all over T1. T1 is 291 is equals to P2 is what? 1 times V2. We are looking for V2. No noise. All over T2. T2 is 273. So we cross multiply. We have that 0.971 times 146 times 273 is equals to 1 times V2 times 291. Is that taken? Okay. So what's the next thing to do? The next thing to do is we are going to divide by the coefficient of V2. So this will be 1 times 291 divided by 1 times 291. Cancel, 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 cancel. You have V2. So we're going to press our calculator. Please, remember what I told us about pressing of our calculator. Do not try to solve the questions all together. Solve them one after the other. Watch. 0.971 times 146 times 273. That will give me 38,702.118 all over 1 times 291, 291 divided by 291, and I have 132.9969. So from the options we were given here, what do you think will be the answer? So the answer from the options we are given here is what? 133, because you are going to approximate 133 answer. That's the answer. Isn't that simple? Let's look at another question. 20 cm cube of carbon dioxide are sparkled with 20 cm cube of oxygen. The question says, calculate the volume of the residual gases after sparkling. This is very simple. Okay, so we're going to write the equation for the reaction, which is carbon 2 oxide sparkled with oxygen will give us what? Carbon 4 oxide. So let's balance the equation. Carbon 1, carbon 1. Oxygen 1 plus 2, 3. Oxygen 2 here. So what do we do to balance it? If we put 2 here, 2 times 2, 4, 2 carbon. So if we put 2 here, it will be 2 carbon, 2 carbon. 2 oxygen plus 2 oxygen, 4. 2 times 2, 4 oxygen. It is balanced. Then the next thing we are going to do is very simple. We are going to calculate the volume of the gases used. The question says the volume of the residual gases. So what will be the volume of the residual gases? Residual gases are the gases that will remain after the reaction. So what are the gases that will remain? The gases that will remain will be 2 gases. 1, the gas that was produced, that is the product. The gases of the product will remain, as well as what? Any excess of the reactant. There must always be an excess of the reactant that was used. So the gases that will remain will be the gases of the product plus what? The gases of the reactant. So let's go. So what will it be? The gas, this is 2 cm cube of carbon dioxide gave us 1 cm cube of this and 2 cm cube of this. Is that taken? Okay. Now from the question we're told that 20 cm cube of this was sparkled with 20 cm cube of oxygen. So from what we have here, you can see that for every 2 volumes of this, you are using just 1 volume. That tells you that we need more of this than this, right? So that is to say that for 20 cm cube of carbon dioxide, if you use 20 cm cube of carbon dioxide, how many will be used? It will be what? 20 times 1 divided by 2. That will give us what? 10. Otherwise, you can say 2 cm cube gave me 1 cm cube. 20 cm cube will give me how many? Divided by 2, right? 10 cm cube. So the next thing to do is what? You can see that 10 cm cube of oxygen has been used, or 10 cm cube of oxygen will be used when you use 20 cm cube. But how many was poured in the eudiometer? 20 cm cube was poured in. So the residual gases will be what? The residual gases will be what? Unreacted oxygen. What is the unreacted oxygen we have here? Unreacted oxygen is what? 20 minus 10. Because what was poured in the eudiometer was 20. But what was actually used was 10. 20 minus 10, that will give us what? 10 cm cube. Plus, now 2 cm cube produce 2 cm cube, right? 20 cm cube will produce how many? it will be 20 times 2, 40 divided by 2, 20. You can also say 10 cm cube, 1 cm cube produce this, 10 cm cube produce how many? 10 times 2, 20 divided by 1, 20. So this will be 20 cm cube. So the residual gases will be unreacted oxygen plus the carbon 4 oxide, the products. Unreacted oxygen plus the products. And from what we have here, the product, which is carbon 4 oxide, produces what? 20. So this times this, that will give us what? 30 cm cube. Answer. Isn't that very simple? Okay, let's look at another question. A certain mass of hydrogen gas collected over water. This should be over water. At 6 degrees Celsius and 765 millimeter mercury pressure has a volume of 35 cm cube. Calculate the volume when it is dry at STP. SVP of water at 6 degrees Celsius equals 7 millimeter mercury. Now, I want to give you a little advice. I want to give you a little tip. Please, whenever you see SVP of water, just know that what they're talking about is that one's law of partial pressure. And before you solve, you are going to subtract the pressure of water from the total pressure in order to get the pressure of gas. See what I mean? Now, let's write out the parameters given. So you have that this temperature T1 equals 6 degrees Celsius plus 273, and that will give us 279 Kelvin. What's in it? And this P1, that is what? 765 millimeter mercury. Now, you were told that the saturated vapor pressure of water at 6 degrees Celsius is 7 millimeter mercury. So where do you have 6 degrees Celsius? This is 6 degrees Celsius. And you were told that the pressure at 6 degrees Celsius for water is 7 millimeter mercury. So you are going to subtract this 7 millimeter mercury from this. That tells you that this is P total. So 765 millimeter mercury minus 7. You must subtract. Even if you don't understand what I taught today, please understand this thing. That whenever you see saturated vapor pressure of water at the degree Celsius, the saturated vapor pressure of water, you must always subtract the pressure from the P total. So subtract this. What do you have? 758 millimeter mercury. If you fail to subtract, you have failed it. And guess what? When you finish solving, you will see your answer in the option, which is a wrong answer. You will see the correct one and ignore it. So let's solve. Okay, then you have what again? Volume V1 is equals to 35 cm cube. What again do we have? The question says calculate the volume when it is dry. So we're looking for V2 at STP. So T2 will be what? 273 Kelvin. And P2 will be what? P2, looking at the pressure we're given, it will be what? 760 millimeter mercury. Okay. I hope you still remembered how we got this. I've given us the values previously. All right. No noise. So let's solve now. To solve, we'll be using the formula. Let's put down our formula here. P1 V1 all over T1 is equals to P2 V2 all over T2. So solving, what would that be? P1 is 758 times V1 is 35 all over T1 is 279. No noise is equals to P2 is equals to 760 times V2, we're looking for V2 is equals to T2 is what? 273. So we're going to cross multiply. What do we do? So that will be 758 times 35 times 273 is equals to 760 times V2 times 279. So we're going to divide by the coefficient of V2 so that we'll quickly get our answer, bearing in mind that if we're in the example We are going to be as fast as possible because time is not going to wait for us. Cancel, 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 cancel. So we press our calculator. So pressing our calculator, you have that 758 times 35 times 273. That will give you 7242690 divided by 760 times 279, and that will give us 212040. So you have that 7242690 divided by 212040, and that will give us 34.157. So approximately our answer is what? 34 what? What are we looking for? We are looking for V. 34 cm cubed answer. Isn't that simple? Okay. So finally, we've come to the end of today's class, and I hope you found value in today's class. Thank you very much for watching, and please do well to subscribe to our channel. Also give this channel a good like so that many other people will watch the video. Thank you very much, and bye.